So we're about to fault find a multi-stage amplifier, and with a multi-stage amplifier it's very important to understand that each one of those stages has its own gain, and the total gain of the whole amplifier is the stage gains multiplied together. So the first stage multiplied by the second multiplied by the third in our particular amplifier. And we ran the figures mathematically on that amp. We found out we had about a gain of 113 times in the final stage. We had a gain of 0.9 times in this emitter follower, and there was a FET stage that preceded that as a preamplifier that had a gain of about 2.5 to 3 times, working as accurately as we could with that circuit. But then there was an attenuator at the front, and that brought the entire amplifier gain down to about 20 times. Now it might be a little bit more, a little bit low. We did take some guesstimates there, but probably going to be a little bit on the lower side than that because of a few losses in cables, etc. So let's aim for about 18 times. Well, we did that. We put the oscilloscope on the output of the amplifier. We injected 100 millivolts peak to peak at the front, and we got a signal at the output which gave us about 17 times gain. That was great. But then that amplifier panel has some switches on it, and the switches are designed to simulate various faults. There's about a dozen different faults that we can simulate on that panel. And in the first lesson, all we did was simulate fault number 1. Now when the switch is up, we don't have a fault. When the switch is down, we do put fault number 1 into the circuit. And with fault number 1 in the circuit, we've discovered that the output dropped from whatever it was. It dropped down about 50% in value. So that got a few people thinking, oh my, what's wrong with the amplifier? And we had people looking all over the amp trying to find what the problem was, but there's a better way to do it, and that is the half split rule. And all we have to do is basically take the oscilloscope from here, put it to the input of the final stage, and then toggle the fault on and off and see if we get the drop in gain at that point. If we don't get drop in gain there, but we do have a drop in gain there, what does it say? Well, it's very simple. It tells us that the trouble is in the final stage. In fact, we did that in class. We put the oscilloscope there. We found that we still had a 50% drop in gain at that point. So the problem is to the left of that point. All right, let's go to the rest of the video and find out exactly how that went for us. So you've worked out then that the voltage on the base of Q2 is changing with fault 1.
Yes.
So what could be causing that?
Capacitor 2.
How would you prove that it was capacitor 2?
Through mathematics.
Well, I reckon with those multimeter leads in your hand, you can probably prove it just as well.
I know, so you're asking a bit there.
If there was a short circuit across a capacitor,
Yeah.
how then would you prove that there was a short circuit with a multimeter? If it was across a resistor, for example, how would you prove that it was a short circuit?
I don't know.
If there was no voltage drop across the resistor,
Yeah.
would that not mean that it's a short circuit?
Then yeah, I guess, yeah, that's true.
So is there a voltage drop across the capacitor? No, you're not measuring across the capacitor. Right, now you're measuring across the
So with the
capacitor.
fault normal, it's just 1.64. Probably change polarities, but and then you got 5.36.
So with the fault, you've actually
It's a big
got
change.
a voltage across the capacitor.
Yeah.
So you were saying that the capacitor was probably short-circuited. I'm going to go ahead and disagree with that, because when we turn that fault condition on, if that was a short circuit, you'd have 0 volts
Completely.
there,
Yeah.
and you got 5.3 volts.
Which
So
actually increased 4 volts.
absolutely, it's increased from 1.6 to 5 volts. So we have not got a short circuit on that capacitor. So what could it be?
Would it have to be something to do with R6 or R8 then?
It must be something to do with R6 or R8. So that's where you said before mathematically. So how about we pull out the circuit and we analyse the circuit, we look at this first stage or the second stage,
Yep.
and think about what's happening.
Okay.
All right.